Hey folks, it's time for another exciting lesson. This is session 12, and if we'll look at our syllabus, we can see that we are actually getting pretty close to the end of the semester, actually. So even though I record generally a little bit earlier ahead, we are still getting awfully close to the end. So I'm actually recording for the week of the 29th, so by the time you get to this lecture, we'll have only about 3 weeks left. So I do want to make another note, is make sure you guys double check on the day the capstone project is due, because it is actually due, I believe, a little earlier in the week. Okay, so double check on that. Today, the chapters are 13 and 14. There's actually a ton of material that we could go over in 13 and 14, but I've kind of selected a little bit that I consider, maybe a little bit more important or pertinent. I'm going to go over some of the topics I go over in the session 12 notes, and also maybe a little bit of information that isn't in the notes about some formatting that you can do with data in C++. So, alright, so that's where we are so far. When you want to do certain formatting, it's important that you include the Manip library that has a lot of important information, or important variables and functions that allow you to do various manipulations on formatting output. So the first thing I want to talk about is, let's say that you want to format numbers in bases other than base 10. So normally we use, as humans, or at least as people in Western culture, and most cultures, modern cultures, use base 10 systems, counting systems, which kind of makes sense because humans have 10 fingers, 10 toes, so it kind of became natural that we would start counting using some sort of base 10 system. So you go from 0 to 9, and then it goes to the next place over, and resets it at 1, so you get 1, 0, that would be our 10, and then 11, 12, 13, 14, 15, and then all the way up to 99, and then we set up into the third place, or what we call the hundreds place, etc. So we talked briefly about that in previous lecture, but you can use a manipulators that are available available for you for input-output manipulation. One of them is to allow you to change the numbers that are printed out to hexadecimal. So you can do this. You can just say cout hex, okay? And this is what we call a sticky manipulator, which means that from now on, past this point, until I change using another manipulator, the numbers that I'll print out will be in hexadecimal. So for example, if I print out 150, right here, it's not going to print out 150. It's going to print out the number in hexadecimal. First to build, so it takes a little bit longer. Okay, there we go. So you notice now it says 96. And what that means is that the you've got the ones place right here, and then you've got the 16s place right here. Okay, so you end up with 9 times 16 plus 6, which should come out times 16 plus 6 is 150. in decimal, which is exactly what we expect. Okay, because 96 is the hexadecimal equivalent of the decimal 150. Now, notice if I do another number like let's say 1000 or 1024. Let's these two. We'll see what happens there. You'll note that it is relatively compactly indicated by 400. Now I want to use a number so you can actually see that in hexadecimal we actually use letters. Okay, so let's look at 13. Now, since that's under 16, we should be able to see that it only uses up one place, and we do notice that it has a lowercase d, because that's the hexadecimal number indicating a 13. E is 14, and then F is 15, and then once you get past 15, you reset to the next place, which is the 16s, and then you have the 16 squareds place, 16 cubes place, etc. Just like with decimal, we have the 10 to the zeros place, which is the one, what we call the ones place, 10 to the ones, which is the tens place, 10 to the twos, which is 100, etc. So that's how a base system works. We did talk about that in a previous section, but since this entire class isn't really about it, I didn't go into depth with numbering systems. But that's hexadecimal. So you can also choose octal. So if you do OCT, it's oct. And when I run this, you'll notice that in octal, I get the numbers in octal. And let's say later on, let's say the first two you wanted in octal, and then you wanted to go back to decimal. Well, you can do that. Since the manipulator is sticky, though, you have to explicitly change it back to decimal. So those are the three that are available: octal, hexadecimal, and decimal. Alright, so that's for the number base. Another thing that you might find useful is when dealing with floating point numbers. 26535. Okay. So we've got pi right here. And let's say we want to make it so that the certain number of decimal points that's printed out is controlled. So normally, if I just print out pi here, you'll notice that it kind of arbitrarily picks what to print out. Okay, but we can actually control that. First, you do fixed, which allows us to set the precision appropriately. And then before you do a cout, just type cout dot precision, and then you pass in the number of decimal places. So let's say 7. Okay, and when I build it and run it, it will print it out with 7 decimal places. Okay, let's say I change that to 4. You notice now that it has 4 decimal places. Okay, so a combination of this fixed variable here. So again, you have this fixed variable, and you have to have that to get it to appropriately display just the precision right here. So, and that's our variable pi right there. Now this could be a constant, but in this case I just used a variable. All right. So you can use this very effectively to determine and to show what number of decimal places you want printed out. So that's the precision. Another topic, one topic I did cover in the notes was obtaining large strings. So if we're done with this stuff for the moment, let's do, we're going not using IOManip right now, so I'm just going to include string. And let's say I have a string, my name, and I say please enter your name, and I'm going to print out my name. I'm going to echo what we call echoing the data. Okay, so if I enter John, it'll print out John, which we expect, and that's good. But if I John P. Baugh, it'll only print out John. Okay, because the stream extraction operator that we use with CN only obtains the first string in this larger string. This is treated as a set of 3 strings, John, P, and Baugh. So the stream insertion operator will only do one at a time. Well, what if we want to read a larger set of strings? Well, we can use a function that's available to us called getLine. And in this case, this particular overload of getLine, you have getLine then source, comma, variable that you're storing the data into. So in this case, we're getting the data from standard input, which is CN, okay, and we're going to store it in my name. All right. So that's basically going to read it all the way up to a new line character. In other words, when the user enters the enter key. So when I print this out, let's see how it's different. And it prints out the whole thing this time, as you'll note. All right. Okay. So that's how we obtain larger strings. The major topic, though, of this this particular session that I want you to pay attention to actually comes from Chapter 14 in the 9th edition. It's file input and output, file I/O, and we know how to read from the keyboard and write to the console. However, many devices and in many scenarios, you're not going to want to do that. You're going to want to read data from a file, write data to a file, maybe read from one file and write to 2 other files, or read from a file and write to the monitor, read from the keyboard, write to a file. There's all kinds of combinations you might want to do. Not everything happens directly interacting with the user. In fact, file I/O is extremely useful and is used in many different aspects in many different programming languages and many different paradigms for all kinds of different things. So it doesn't always use C++, but even an app on your mobile device, a lot of times if it needs just a little bit of data, and you don't, the programmer didn't really need to interact with a huge database or something like that, a lot of times they'll just store information in small text files and pull the data in from there. That's actually very common. So knowing how to interact with files is important in any language that allows it, and C++ is no exception. So we're going to learn how to read information from a file and write information to a file. Now, Iostream, which we've seen before, is used for interacting with the keyboard and the monitor for our purposes. It's for the what we call standard input and standard output. Standard input's the keyboard, the standard output is the console, which gets displayed onto the monitor. But in this case, I'm going to actually, instead of string, I'm going to include fstream for now. Actually, we're going to be using string in a moment, so let's include that too. But fstream stands for file stream. That's used so we can interact with a file. And there are 2 different variable types that we're going to utilize from fstream. One of these types is ofstream, and I'm just going to name the variable outfile. Ofstream is for output file stream. This is a variable that will interact with a file that we're using as output. Okay, And anytime you use a file like this, you have to open a file, and then you should close it before or when you're done. So think of these almost as curly braces. You have to open and close. So outfile.open, and I'm going to call it output.txt because it's a text file. And then later on, I'm going to have outfile.close. All right. So I open the text file, and then I close it later on. The text file is going to be named output.txt, but I could name it output.dat for dat. That's used a lot in Unix. But on Windows, since we have txt, and that can be easily and quickly opened with Notepad with no fuss, no problems, we're just going to call it output.txt. All right. Now I want you to carefully observe something here. When I actually want to write to file, I just type the name of the file output variable, then the stream insertion operator, just like we'd use with cout, and I'm going to put hi, my name is John Baugh, out file, and then this is a file I'm writing to. All right? Okay, so it looks, the syntax and even the variables that I'm using, endl, and the operators, the stream insertion operator, is identical to what I would use with cout. The only difference is that instead of using cout, which is standard output to the console, I'm using my variable of type ofstream to write to a file. Which file? The file that I specified in open. Okay, so let me build this. All right, and I'm going to go to debug, start without debugging, and you'll notice that all it says is press any key to continue. And you might think, well, wait, where did the data go? Well, we didn't tell it to print anything out to console. There's no cout statement here. We didn't say to print anything to console. What actually happened, if we go through the file system, I open up Windows Explorer, and I'm going to navigate down into the work directory, and I called this session 12 file IO, etc. We have this in here, and if I go into debug, since I'm compiling in debug mode for the configuration, if I go to here and then go to notice that we're under. Sometimes they'll put the executable in the debug, and you would have to send this with or load this onto a CD or onto a flash drive or up on the web or whatever, and you would. If you loaded it from here, you'd note that the file would be written in the same directory. But I misspoke a little bit. If I go into this project file, because this is the solution folder, correct? This is the solution folder. This right here is the project directory, and by default it writes when you run it from Visual Studio, it writes in the project directory in 2012. Some other versions might write in the debug folder or somewhere else, so you'll have to kind of look around. But we have this output.txt. If I open it, you'll notice it has the text that I just told it to write, which is exactly what we want. And again, you'll note that if I just double click this executable, notice how it wrote the output file right here. That's because I wasn't using Visual Studio to do it. So it wrote the output file in the directory right next to the executable. Visual Studio does some interesting things to make it write it in another directory. Okay, so all right, so that's output. The next thing we're going to do is input. So reading from files is important as well, and that's a little bit more complicated, but it's not too much so. In this case, let's delete these. We already have our file that we're going to read from because I just created it. This time I'm going to use Iostream and call it infile. Now again, you can call it anything you want. You could call this is a variable, just like an integer or a string or a character. It is a class that someone defined for us, okay, of type Iostream. It's not a primitive data type, so it's more like string or company class or employee class. It's a little more complicated. and does a lot of really interesting things for us, but it is a data type. So we could declare a variable of this type. In this case, I'm naming it infile. If you want to call it input file or something like that, that's fine too. And I'm going to declare a string, since we're reading string data in from file. I'm going to say infile.open, and I'm going to open output.txt, which is the same file that we had from earlier. And later on, you're going to do infile.close. I generally do this first so I don't forget to close it. Not closing a file can have unintended consequences, especially if you have many different opening and closing, or opening calls in your program, or you try to open it with another program. It may get what we call a read lock on it, or sometimes a write lock on it, which means that you may not be able to modify it or even access it in some cases. So you always want to close it so you signal to the system that you're done with it. Now here's where it's a little more complicated. It's not too bad though. We're going to use a while loop, and the case, the condition for the loop, the termination condition or continuation condition, is that we say while not infile.eof. Now what does this mean? Well, this little member function, remember this is a class. Ifstream is a class, and we have infile, which is an object of that class. EOF, with open and close parentheses, EOF is just a member function of the Ifstream class. Okay, so this particular object calls EOF. Now what does EOF stand for? EOF stands for end of file. And we're saying, while not end of file, so as long as we haven't reached to the end of the file, we're going to do something. Now what's the something that we want to do? Well, I could use, I could just say infile and then use the stream insertion or extraction operator, and then send data into variable word by word. But since we have larger lines in this file, I'm going to use getLine, which we saw a minute ago. Now, I'm not getting the data from CIN, though. I'm not reading it from standard input. Where am I reading it from? Infile. And then where am I putting the data? I'm putting it in temp data. Once I read each line individually, I'm going to use cout to print it. Now, you could do anything with this data. You can concatenate it to another string. You can print it to another file. But in this case, once I read the data from the file, it just seems natural, just to make sure we're reading the data appropriately, that I print it out to the console in this case. So I'm showing you that you can mix the cout operator and infile. You can mix them any way you want, really. And not surprisingly, I have this data right here. My name is John Baugh, and this is the file I'm writing to. And then the program ends. So that's pretty much what you need to do. So that's pretty much the topic for this week. It's relatively short, but I'm going to go to the discussion board and see if there's anything that needs covered. I think there are a couple things I need to mention. Just inserting. Okay, so I don't see any new discussions, so there's not really any new data. I have uploaded the information, the notes for session 12, and I will, once this video is done, you'll see a link for that. The other thing I wanted to mention is that project number 2 has been graded, okay, and also if you're watching this early enough, project number 3 deadline was extended, okay. Since it was popularly demanded, I have made it due on August the 2nd. Okay, so you have a little bit more time to work on it. So you should have gotten an email and or just check the news items when you log in, and you should be okay. But you have an extra week to work on project 3. If you guys want an example of some sort, or you want a little bit more information, I will try to provide something for you, but I haven't. I try not to just do everything for you. If you ask pointed questions and specific questions on the discussion board or an email, I will try to answer them the best I can if I understand what you're asking. Um, so just please take advantage of the discussion boards, and also, take advantage of email as well. I mean, email me if you didn't do as well on project number 2 as you had hoped, or you're not feeling confident with project number 3. Then you need to contact me. There's nothing embarrassing about contacting me and say, hey, I just really don't understand this stuff. What gets embarrassing is if we're in, late August, and the class is, well, not late, but mid-August, and the class is pretty much over, and then you come to me and ask me about project number 1. That's not embarrassing because, you should be embarrassed because you don't understand something. It's because you didn't get on the ball and come ask me earlier. You need to ask me as early as possible. So you still have time to ask me about any of the projects that you want to make up or try to work on, but I'm not going to come out here on the day before class ending and have 15 people asking me to sit there and show them how to do every little step in every little project. Try to get to this early. I will show you and walk you through some of the stuff in maybe project 2, or give you some ideas with project 3, but I had a few people, you didn't really turn in anything. That's not a good indicator for project 2. So project 3 is by far the hardest. So if you did well on project 3, then you're doing very well. I know a couple of you have done really well on this, so that's good, but many of you are struggling. So that's kind of expected, but if you need any help, please come see me. Project number 2 was fairly straightforward. If you didn't get the grade you wanted, that's okay. If you come in and see me, or we talk about it and you want to resubmit it, or maybe you realize what you did wrong and you want to resubmit it, maybe you accidentally submitted the wrong thing or didn't submit anything at all and you thought you did, then you can turn it in. I'm not going to take off a ton of points. It's better to get this than to have like 20, 30, 40 points taken off 50. Some of you had many, many points taken off because you didn't follow instructions or didn't do what you were supposed to. My office, I was in today, and I'm actually going to be in a little bit Thursday evening for a student or two, actually a couple students. So I've had a couple students visit me today and a couple visit me last week. But if you're in the area and you can meet with me and you want to meet with me, we will try to arrange a time that's good for both of us. So, well, I appreciate you guys. I hope everything's going well for you, and again, contact me if you need help. Don't drown. Okay, you might be getting in slightly over your head at this point, but you're not drowned yet. We've still got a few weeks left. So just email me and say, hey, I'm really, really struggling with this, and I'm embarrassed to talk about it, or whatever you're having a problem with. I will try to work with you on it as best as I can, without giving you everything. But, all right, so I want you to learn. All right, so again, this was an extremely short lecture, but there is a good quantity in the notes, and I also wanted to make sure you had time to work on your assignments. So if you have any other questions, please email me or post in the discussion board. Again, email me jpbaugh@oaklandcc.edu, jpbaugh@oaklandcc.edu. Thanks, and have a great week.